Often when we're going to represent our data, we need to represent it using a graph. And a graph is a new way of getting a picture from numbers. So what's useful about it is it helps us see patterns, and we've got different graphs. The main graphs are pie graphs, bar graphs, histograms, and line graphs. Now, to be honest, you're not going to use a lot of pie graphs, bar graphs, or histograms going forwards. They are quite simple graphs. Line graphs, where you're going to have to consider whether you've got a gradient, a straight line, a parabola, an exponential graph, or a hyperbola, is what you are going to use most of all going forwards. Whenever you draw a graph, you must include a heading, and the heading is always a graph of whatever's on the y-axis versus whatever's on the x-axis. You're always going to put the independent variable on the x-axis, in other words, what you changed, and whatever you measured goes onto the y-axis, the dependent variable. You label your axes and you put the units of the measurements in brackets. The values of the axes must be represented in evenly spaced scaled units, and I'm going to come back to that in a short while. The scales on the x and y axis don't have to be the same. So, as an example, let's say we said graph of So over here I've just drawn something very quickly. I've said a graph of number of bubbles produced versus time. Let's say we were doing an experiment and it made some bubbles. The independent variable, I chose the times. So let's say 1 second, 2 seconds, 3 seconds, 4 seconds, evenly spaced. You must put the 0 in, and that is your even scale. And then I would go, let's say, 10 bubbles, 20 bubbles, 30 bubbles, 40 bubbles. It's not the same scale as the x-axis, and it is evenly spaced as well. I don't go, because after 1 second I had 5 bubbles, after 2 seconds, let's say, I had 12 bubbles. I don't go 5, 12, 17. I evenly space this axis over here. Then my dependent variable is what I measure, number of bubbles, versus the independent variable, and the number of bubbles is on the y-axis. I try and start at 0, not always, but most of the time. I'm not fond, and nor are the examiners fond of the zigzag thing where you half chop away part of the axis. Try to start at 0, means that you can compare exactly what's going on from the starting point. So at 0 seconds, there were 0 bubbles. Pie charts obviously don't have axes, but they must have headings. So it's a pie chart showing people's preferences in movies. The full 100% must be represented, so that if I had 100 people, 8 of them would have liked, what was that? That looks like it's science movies. 8 of them would have liked foreign movies, 11 of them horror movies, etc. Each percentage is represented by 3,6 degrees. So if I take something like 8%, I would multiply that by 3,6. So it would be around about 20 degrees, 20 degrees. And you land up having 360 degrees and 100% all represented. Bar graphs. You get bar graphs are usually, the horizontal axis doesn't have numbers, but rather words, like apples, pears. So it is a graph of the fruit sales in April 2007. The number sold, notice the even scaling of the numeric axis, and then we've got apples, pears, mangoes. It doesn't matter what order you put those in. You could have gone pears, apples, plums, oranges, grapes, melons. It really doesn't matter. They're not linked to each other, so there are gaps between the bars. The bars should be more or less the same width as the gap. Usually the spaces are left between the bars. Histogram is slightly different in that it usually deals with groups of continuous numerical data. So the salary of people in thousands of dollars, the number of employees who have between 0 and 10 is, let's say, 50, 11 and 21, 300. You can't suddenly put 44 and 50 to 54 somewhere here. There's a clear order that the numeric information on the x-axis also needs to go. And they are joined to each other. After 10 comes 11. After 21 comes 22. And because of that, they touch. And the order of those bars is important.